So this is just a short video to show a lot of work has gone wrong and then something went right. So first I went on a limb and I tried all these settings and I had to reverse engineer, and I thought maybe on the adapter, which is this by the way, so make a larger video later. I soldered it up, it's in the device right now. I thought I had the ADC here, but then when I actually measured it, it was down here. Then the second problem I had was that when I switched it on, I had incredible large swings here. And it was only like between 2 and 3 times lower measure than what it showed here. So then I figured out, yes, the gain must be incorrect. Sorry. The gain must be incorrect in the firmware. And then I found out that in the firmware that I have here, there's no gain control, it's only offset correction. So, and what that means, if you look at let's say this is the set point and this is the actual measured value, then the offset is when you have 0 degrees. Where does it cross the line? Here it's supposed to cross at 0, so you have to compensate. And the slope of the curve is not correct, that's the gain. So after a little bit here and there, I measured 2 points. First 200, I set it to 200, got 123 degrees. I had to clear the offset also here though, before I started trying the firmware. I set this to 0, just to be able to see what I get, and then took a second point, which was 400, and I got 207. So to calculate the rate of change, you take y minus y, like here, and then you take x minus x, like here, and then I get 0.42. So that's the value I will use as gain here, 0.42. It can be tweaked a little bit more, but it's a good starting point for now. And the offset, that's b in this equation for a line. Anyway, it's very easy. You take one set point, for example this point, so y is 123 minus slope times x, you get 39. So I put that in the firmware. Yeah, 39. So when I program it, I can show you how I do that. You go into Mini Pro. Well, first you have to go into here, save, and you compile, and you'll see it's done compiling, and then you do a sketch export binary. So then you don't have to go into your temp folders like down here like I did before. But so you go into Mini Pro, you go to code memory, you say open, open, and then the standard hex file, Intel hex code memory. Okay, so now you have the hex file in here. You also have to do the configuration. I have already done it. It's supposed to say E2DF FD. I did something wrong, so it says 3D, but doesn't matter, it's FD. So, and you have to check ICSP port if you have the Mini Pro, and then turn off this one, because if you have this one on, it doesn't work. Also, because the way the microcontroller is wired up, you can't verify when you have it in circuit. So, and also then check IDE. Maybe something wrong in the chip or something. So I don't code the data memory and all of this. It goes faster if I don't do that. So now you can see it's working. There's no verification, but I think it's okay. It's not a big problem. config, it sets config. That means it pulls the config out to the default values and then stores it into EEPROM. So if I switch it off and then back on again, like here. Also be very careful, this is mains, so if you touch anything around here you're going to get a lethal shock, so don't do that. So that's my little disclaimer for today. So it says cradle, it's not in the cradle, so I'll just use my magnet over here, there, so I fooled it. I think that I put it in the cradle and out again. So now the set point is 100, so let's see where it goes. And the regulation part here is working just fine, so I'm really happy about that. Probably can be tweaked, so whatever this one thinks is 100, it regulates to 100 just fine, and 300 and 400 no problem. Now with the correction that I made, you can see it gets pretty close. I'm not sure if the thermocouple is supposed to stay like that, but you can see it changes a lot if you start moving it around in there. So yeah, so anyway, I'm happy with that. So let's try 260 then. Be careful, don't touch anything here. So I'm holding my finger like this. Hold on, I'll try doing it safely. I have a lot of video, but there's a lot of fiddling, so this will just be a short demonstration. I will show the struggle later. So 260, and the actual temperature is going sky high over there. So, so something is not very great, but it's not supposed to measure inside here anyway, so I think when this moves around, you know, so it's just changing. So yeah, but I'm happy with the measurement I have now. So you can see, I think I had it there when I calibrated it, so you can see it gets very close, just right at the tip. So let's try 300 and 60, let's say something. You can see the heat shrink has disintegrated, so that's why I started coughing in the beginning of the video. So yeah, so it's a bit, oh well, it's climbing, so no, it's a bit off, you can see at 360. So yeah, well, I'm happy with that for now. So it's not that easy to do. You can tweak the values a bit more, and of course it's using a liner scale like this, just calculating the rate of change, and then the offset, it's not perfect, so I think I will have a better setup, and then I'll take more measurements and maybe make a square fit or something. So, and there you can see the board. That's another struggle that I had. You see it? Just going to turn it off first. Put it into the cradle. Yeah. So the thing with this firmware from Madwarm is that if you press the buttons 2 times, you can get fan only. So that's nice. So, and I will show you the struggle later, so I'll just turn it down for now. You can see the board in there. So you can see my little hack. And the reason for that is because I needed 2.5 volt reference, because this microcontroller, very small little microcontroller, this guy, which goes onto here. um, it's an 80 mega 328p, so it doesn't have a 2.5 volt reference for the analog reference, so the analog to digital converter. So therefore I have used a TL431, and that's the one you see in the schematic. It's basically, I can just draw it faster than finding it. So it looks like this. 2 resistor, 2 capacitors, another capacitor, and then a resistor in between. So it's a low pass filter times 2, and then this is the V in, and then you have a ground, and over here you have the TL431, same as I used in the C64 saver. And it's when it's connected in this way, you have a, if you call this VRF down, then you will get about 2.5 volt, very close. And it will also be very stable and have little noise on it. You don't want noise on your ADC. So yeah, and I figured out what these pads are for. Hold on. So look here. I figured out that these pads, it says R1, R3. If you connect 2 resistors there, the same size, like 10K, 10K, then you divide the VCC and VDD, or 0 and 5 volt in 2, and you get 2.5 volts as reference. So that was probably what the maker of this board was thinking. So yeah, I've tried the the website, but it doesn't work. So it would be nice to have a schematic. And also, while you're here, I also have a discussion going. Let's see, at EV Blog, you page 19. Actually, it's really long, this EV Blog discussion. So hello BWAC, there you go. So that's what I'm measuring. So I thought I had something wrong here, but it was okay. So after a lot of ado, I found out I was missing external reference, because I was looking in the firmware and then it says internal, use internal. I was thinking, okay, well, no, external. But I was, okay, well, there's no external. So let's see, there you see ADC reference. I have put this in there. Then I figured out, okay, then I need internal. Well, this 80 mega 328p doesn't have this 2.56 reference, so so then I was off square again. So then I did the manually take it to 2.5. And the reason for doing that is when you get the thermocouple comes in here, which measure inside here anyway. It's a tip, or I think it's in here or something. Then it goes into the OPA amplifier, and then up to the microcontroller, which is now the board that I have. And that voltage is like at 500 degrees it's about 2.44 volts. So, and 500 is the maximum, so to speak. So to get it into the range of the, to get the better resolution of your ADC, you will have better results if you set a reference to 2.5. So then you have a little bit headroom above 500, or else you are pissing away a lot of bits, you know, so in your resolution. And yeah, so discussion I will link it below, so I'll make videos later. I'm very busy now because I'm reading for school, so for the exams and my labs and stuff. So I don't know what's more to show you. And yeah, I ordered this. I was thinking putting bimetal thermostat, so you can connect this with the mains in series with the heater, and then if this gets too hot it will cut the power. So also the first time when but I'm not going to do that because well, I don't want to fiddle too much with it anyway. And then if you want to cut the power, you just to the heater anyway, you disconnect this one, of course, this one in the when I touch there now, it has mains on it. So so turn off the power, unplug here like this, and then you can safely unplug. Yes, I think that's it. Probably forgot something, but you will see a video from me soon. But right now I'm too busy, so yeah. So now I forgot to say if I actually showed you what I did in the firmware. It's the header files. Sorry if I'm doing this twice. So this is my offset. And then the gain that I talked about in the very beginning was very far up here in the code. It's in the beginning, so this is my gain. So, and this is what the firmware says. I think I will put this in the firmware as a part of the configuration part, because it's possible to configure this while you're in the in runtime when the device is on, like here. So we'll put that as a gain somewhere, so it doesn't have that. But for this model, it's really really important. And you can also see the board that I have is 858D04 PCB 2014 0609, so .09. So yeah, so I'm looking forward to edit the video, but I'm not looking forward to sorting all the video clips, because there's a lot of clips. I did some video about this calibration, but I just deleted it because it's not so straightforward always. So yeah, and also I had struggled with I had to disconnect the microcontroller all the time, or the board, to program it, because this TL866A programmer with in-circuitry programming port didn't want to work for me. So, and also there's a catch. I can show you. You can see read switch. That's the cradle. So when you have this one in the cradle, then the read switch is closed. So I think. So then when it's in the cradle, the MISO, which is the master in slave out, doesn't work. So you can't program when this one is switched. So it's a bit sad that that one was used for that. But anyways, that means just you have to take it out of the cradle to program it. Now the other thing is if you have a programmer that can do ICSP with the TL866, then you must not forget to remove this one. So it's a bit sad when I do this every time. I have to do this. So that's the so you don't power the microcontroller from the programmer, but the device itself. So now if this one is unchecked, the TL466 will only sense that there's power present and not provided. Then you remove the verify after, and then check ID. So, and here's the correct ID. I think I said that already. So sorry for the shaking video, but that's the update. So I don't have time to edit the video right now. So holy crap! I can show you. I also have some screen stuff. Let's look. see, yeah. Not sure what I think I'm working on the yeah, it's the Arduino. So yeah, without audio, of course. 858D mods part 2, and you can see it's very long. Let's see what I'm doing here then. I think that was the first time I got it to work, so yeah. Then I had some problems with the watchdog timer, which is supposed to not be so fast, and so yeah. So here I'm sitting thinking, and probably more reverse engineering. I don't know. I will cut this video down a lot because I went on a tangent, and not this video, but these videos, because of these two, where I thought I had that the switch was mixed with you can see these resistors right there. Those are from the buttons, 220 pull down to the button, and then a 10k pull up to 5 volts. So I thought they went down to the ADC. Sorry, the op-amp. So yeah, made a lot of videos with the mistakes. So yeah, I don't know if there's more to say for now. So, but that's the state of the project. I'm not sure I will recommend it. It's a lot of work to get it to work properly. The regulation part was easy, but the calibration is not so straightforward. It would be nice to have like a program in the firmware that asks you to do certain things, and then when it's stabilized, you watch the actual temperature, and then you just push the button to get it right, and then it goes to the next step. So let's say do 5 points over the whole scale, like it measures around 5 points. And then it puts that in an EEPROM and use linear approximation, interpolation. So yeah, so that will be great. So then you get better calibration. So yeah, thank you for watching. So I think that's about it. Bye bye.